Hello good people, this is Jason Irvin, aka The Janitor, here bringing you another episode of Wash, Rinse, and Repeat. Now today's Wednesday, February 20th, and so that means we're going to be continuing on our journey on the overthewire.org web series. Previously we've done exercises 1 through 10. Now we're focusing on exercises 10 through 20. We want to move a little faster since we've already got the tools, techniques, and also some of the commands that are going to help us move forward a little faster. So without any further ado, let's cue the intro and get right to that terminal. Okay, so let's get it back started. We ended on levels 9 through 10. Now we're going to start on Bandit levels 10 through 11. So the first thing we need to do is go ahead and SSH into the Bandit 10 box. So you know what we need to type there, SSH Bandit 10, where we're going to, the port, and put in that password that we have. And this level states that the password for the next level is stored in the data.txt, which contains base64 encoded data. So let's go ahead and type ls-al, and we see the data.txt file there. And let's go ahead and type file data.txt to see what type of file it is. We can see that it's an ASCII text. If we cat that, we can see the base64 encoded message there. Now base64, people use that for trying to encode different messages to make it look like a password, but it's actually not encryption, it's encoding. We're going to go ahead and cat the file, so cat data.txt again. And we're going to pipe it to the command base64 and type --decode. And there we have it. We have the password that's what our password is. But I want to show you something else. If we type echo and that string, that line there, and then we pipe again and put base64 there, you can see that we have now re-encoded that same phrase. It's exactly the same into what you saw originally. So let's just go ahead and copy that password and put it right into our text file. And that one was easy. We learned about base64 and we're moving right along. Hit the exit. Let's jump out of this box. Let's move on to Bandit 11. Press the up arrow and we will change that 10 to an 11. Not a 12. Hit enter. We're going to put in the password and let's read what this one says. It says the password for the next level is stored in the data.txt file, once again, where all lowercase a to z and uppercase a to z letters have been rotated by 13 positions. Okay. This also recommends that we read something about rot 13. So let's open that up. We're going to cat the data.txt file, and you can see that it's just more gibberish, or what seems to be gibberish. So let's see what rot 13 is. So rot 13 is a simple letter substitution cipher. And there is actually a table I found through some Googling that will give us the TR commands for all different rot types. I want to quickly give you a new command, the TR, which translates or deletes characters. Let's just copy this TR and paste it in here. So we're going to cat the data.txt again. What we're showing is that we're moving the characters up 14 characters ahead to make the rot 13. And we're saying that that first one is just replacing the N through Z, A through N, both uppercase and lowercase, and for all alphabets is what that's saying. We put that in there, and now we can see that the password is, let's go ahead and copy that and put that into our text document. And what I would like for you to do is to take some time and go read over that TR command as well as what rot 13 is, because that's used in a lot of CTF challenges that you may see. So let's move right along. We're going quick. The next thing we're going to do is go ahead to Bandits 12 through 13. It says the password for the next level is stored in the data.txt file, which is a hex dump of a file that has been repeatedly compressed. It sounds like fun. So let's go ahead and jump into that box. We're going to SSH into Bandit 12, put that password there. And we're on this box. First thing we do, ls-al, we see the data.txt file, so let's go ahead and cat that again. And it is definitely a hex dump file. So you'll see a hex dump file in things like network traffic. There's a few other things we can do hex dumps, but network traffic is one of the main things that comes to mind. But there's a command I want to show you here. It's xxd. So let's do a man on xxd. And man xxd makes a hex dump or does the reverse. So if we have a hex dump, which is something we have here, we want to reverse it to see what's actually there. So how do we do that? Let's go ahead and scroll down a little bit. And we're looking for that R for reverse. I just want you to see it. Reverse or revert. So there's our -R operation. We're going to take our data file. Let's do an ls again, look at the data text. And it recommends that we move this file into a directory that we create. So let's make a directory from root, call it temp and the janitor. So we're going to mkdir, make directory from temp and call it the janitor. Then we're going to copy the data.txt file into the temp janitor folder. And let's go ahead into that directory. So cd temp the janitor ls, and we can see that our file is there, so it did move. And we'll do the xxd command with the -r for the data.txt file, and we need to redirect that file, so the output of that file, into a file that we're going to call reverse_data, ls-al, and you can see that we have the data.txt file as well as that reverse data file that we've created. And if we do a file on that reverse_data, we can see that it's supposed to be a gzip compressed data file. So gzip is the same thing as like a zip file, but it's actually a gun zip. And this file is supposed to be gzipped. So we're going to move the reverse data file and rename it. So when we do a move, it's taking it from the original file and moving it to a new name, reverse_data.gz. We do a ls-al, we can see that that file is there. And I wanted to do a man on how to deal with a .gz file. We type man gunzip, and you can see we can use gzip, gunzip, or zcat to expand or compress this type of file. And we're going to type gunzip, the file reverse data.gz, and let's type a ls-al again, and we can see that the file is now just reverse_data. So let's see what that is. So if we do a file on reverse data again, now it's a bzip2 file. So it did say that it's been compressed repeatedly. So let's move this file into a bz.bz2 file. So we're going to move this file into its proper container, a .bz2, which is the extension for a bzip file. So let's take a look at that. Let's go ahead and do a man on bzip2. You can see that command actually does exist there. Now, when you have a bz2 file, you can see that it's compressed. So we need to decompress that file. Before we do that, I want you to see what it looks like if we try to do it just like the other file. By typing bzip2, let's ls-al again, to show you that the file is there, the reverse_data bz2. So we're going to bzip2 reverse_data.bz2, just like we kind of did with the previous gunzip file, and we get an error. It says input error, input file reverse data bz2 already has a bz2 suffix. So this is telling us that if we had did it that way, we will be creating a file called reverse data into the BZ2 or a BZ2 format. So what we need to do is decompress that file. So let's look in the man pages and make sure that we're able to decompress the file. So the -D is the way we do that. So bzip2 space -D, because this is a compressed file, we need to decompress it. We do bzip2 -D and the file reverse underscore data bz2. And if we do a ls-al again, we can see that it's changed again back to reverse data. So let's do a file on that and see what it actually is. Now it's changed back to a gzip file. So let's put it back into its proper container. How do we do it? MV, so we're gonna move the file again, change the name from reverse underscore data into reverse underscore data dot GZ, just like we did previously. ls-al, we can see we've changed it into a .gz file again, and we're going to gun zip it. And there we go. We just did it again, ls-al. Let's do another file on this reverse data file. And now it's changed to a tar file. Good Lord. So now we have to rename it again, but put it in its proper container as a .tar file. But first, what I want to do is do a man on the tar file, on the tar command. It's an archiving utility. And let's explain how to actually get this uncompressed from a tar, from within a tar container. We know we want to extract it. There it goes right there. So we're going to extract it. X is going to be one of our commands. I'm looking for V and F, really, to kind of show you what those do. Should just do a search for it, but should be really close here. Okay, this file's a little larger than what I originally thought it was going to be. So let's just go with it. We're going to tar xvf, so we're going to extract verbosely the file, and it's reverse underscore data.tar. And we see that out of that tar file came another file called data5.bin. First, let's do an ls-al. Now we're doing a file on data5.bin, and we can see that it is a tar file as well, but it has a bin container. It wants us to believe that it's a binary file, but we're going to move that binary file and put it in its proper container and change it from a binary into a .tar file. We're going to do the same tar xvf data5.tar. Now we have a data6.bin. Let's do a file on this file. And this one is just a bzip2 container. So let's move this one. And again, do what we've done previously. So we know with the .bz2 containers, we have to decompress these. So we're going to bzip2 the data6.bz2 file. And I keep forgetting to decompress. And let's do an ls-al again. And now we have the data6 file out of its container. Let's file the data6 file. And it is in, it now wants us to put it in a .tar archive. So we're going to move data6 into data6.tar. Then let's untar that. So tar xvf, the data6.tar file. So tar xvf data6.tar, and we have data8.bin. Let's do a file on data8.bin. And this needs to be in a gzip container. So move data8.bin into data8.gzip. You should be a professional at this by now. Now that we've done that move, just gunzip that file, data8.gz, hit enter there, ls-al, and you can see here that we have data8. Let's see what file that is. And finally, we have an ASCII text. So let's cat this data8 file that we have now. And we finally have gotten our password. That was a long one, but you should now be well versed in containers and being able to move files so that they're in containers. So we'll copy and paste this into our log file. Bandits level 12 through 13 are now complete. So this week we learned about base 64 as encoding and not encryption, and how it can be decoded and also re-encoded. We talked about ROT 13, which is a substitution cipher. We decoded it and really broke that down into how to do that with the TR command. We've learned about hex and using XXD to decode the hex text. And we've done extensive work with containers and putting files in their proper containers and uncompressing them. Although we only did a few exercises, we did touch on a lot of subjects. And next week we'll continue on our path. I really want to get us finished through these Bandit exercises so we can get to some more in-depth concepts, but we have to start somewhere. And there's no better place than this. Again, I'm Jason Irvin, aka The Janitor, and I'd like to thank you for watching another episode of Wash, Rinse, and Repeat. Always remember, stay focused, never quit.